Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GravWell is the solution for you. GravWell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GravWell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/Security Weekly for an unlimited data trial and gain uncompromising visibility today. PlexTrack is the platform that guides the healthy collaboration of red and blue teams to get the daily security work done. Red teams can create reports in half the time and track risk to resolution with the blue team. Blue teams can centralize remediation efforts across all scans, assessments, and audits through simple visualizations of risk, scanner, and ticketing integrations. Enhanced analytics allow you to effectively communicate risk in real time. PlexTrack is perfect for remote collaboration across all teams. Visit securityweekly.com/PlexTrack to claim your free month today. Welcome back, everyone, to Paul's Security Weekly. Learn how to prevent account takeover attacks in our next webcast with Google Cloud. You can register for our upcoming webcasts at securityweekly.com/webcast. Catch the previously recorded ones on Security Weekly /on demand. This one with Google is going to be interesting. They have a full-blown bot detection platform that they're calling Recaptcha, and I know you think about CAPTCHA as the thing where you have to highlight the crosswalks and fire hydrants and traffic lights, which is highly annoying. They've got a way better one that they'll talk about the progression and everything that's been happening with Google Cloud and the security teams. So super excited about that. Ben Mussler is a web application security researcher at Acunetics and joins us today to talk about the new web technology and its impact on automated security testing. Ben, welcome to the show.
Hi, Paul. Well, thanks for having me. It's great to be here.
Yes, nice to have you, Ben. So, Ben, you wanted today to talk about something I find really interesting, and really it represents the progression of applications that are running in the browser that want to behave more like a native application on the operating system. And I really, truly think this is the future. I think native applications are going to slowly go away over the years. And it's the APIs within the browser that you're going to talk about today that will enable that, as well as some automated scanning, as well as probably some security concerns as well.
Absolutely. Well, actually, I want to take a look ahead at what the future might bring and what it means not from the point of view of developers, but from a security point of view, what it means for automated security testing, what it means for web security in general. And I would also like to talk about what it means for those of us who want to stay on top, who want to be aware of these features, because many of them are already available or already in the browser. So it has a certain impact on users and on websites.
But when it comes to automated security scanning, I mean, basically several years ago, we figured out that we need to have an actual real browser in our scanning engines, right? And there's been this kind of progression from WebKit to maybe Selenium to perhaps Chromium. I don't know if you can talk about kind of that progression and what's being used today.
Yes, absolutely. I would like to go back first to give some history about the development, about the evolution of how websites are being made, basically, because I think it's important to have that as a backdrop to what I'm going to talk about. So when you go back, let's say, to the beginning of the web, you had static web pages that you would usually create on your own local system. You would upload them to your web server, usually through FTP. And in the end, the user, the client, would access the same pages, download them, render them. So that is the distant past, but it's still important to begin, well, with a beginning. And then at some point, we moved on to having server-side dynamic web pages, for example, PHP. So you would have interactivity. You would allow the user to interact with your site. You would be able to do more interesting things.
Now Ben, it's funny. As an interesting side note, I remember in college in the 90s, because I'm old, I was sitting in, I had to take this basic Microsoft Office application class. And I'm sitting in the class bored to tears until one day my teacher was like, hey, there's this thing called the web. And check this out. There's this new thing called CGI. And if you put a bunch of stuff after the URL, you can get websites that do interesting things. And that's all he said. He gave a short demonstration. And I'm like, so wait, websites can be hacked. Like, I want to do this for a living. It was one of the things that like really made me want to go into security.
No, absolutely. And then at some point, we moved on towards something that made websites dynamic on the client side. Or at least we had it before, but it became more popular. Let's say you had a website where the user needed to enter data, and you would first try to verify that data client side before you send it back to the server, just to improve performance, just to make the web application feel a bit more responsive, because you would not want to send one single request every single time the user fills a field in a form. So you had suddenly more dynamic applications, and they were dynamic on the client side as well. And this really culminated into interesting applications like Google Sheets, for instance. I mean, if you look at Google Sheets, I think it was released 10 years ago. I'm not even sure, but if you go further back, it was inconceivable to have a spreadsheet application similar to Excel running in your web browser. Because then you had things like Ajax available, you had client-side dynamic code available, and suddenly you had Office applications in your browser that combined the best of both worlds, client-side and server-side. And I think this was an interesting shift. And then now slowly we're moving towards something called progressive web applications, PWA for short. And yes, so that's what I'm going to talk about today, basically.
So
what I think,
go ahead, Matt.
Sorry, I was going to say, I think what's interesting is I went through that transition period in my career when we built Control Path way back in the day. We went from a static page kind of hyperlink user interface to a full Ajax web interface. And back then, this was early 2000s, we were building this app. But as you were going through that progression, remember the 3-tier application? Well, when you introduced Ajax type technologies and JavaScript and put pages on the browser, you actually created this 4th tier of how the applications actually interacted. And it created a lot of interesting challenges from a security perspective, because we were so used to protecting the server side of the equation. And now we were putting parts of that application at the client side.
That's correct, yes. And well, what can I say? It will get even better, because now we're seeing that web applications want to behave more like native applications. They want to, let's say the browser is becoming the new operating system. And in order to really feel more like a native application, the browser needs to offer more functionality to the web application. For example, direct file system access. And that is something that web applications did not have, but that they're going to have soon. And I don't know, does that sound surprising? Does it have any implications? Yes, it does. And I think it's important to understand that most of us who use Google Chrome use a browser that already has code to allow for file system access.
That's interesting. I mean, is that different from, basically I write JavaScript to allow users to upload a file, but I'm not really able to touch the file system. It's just based on what the user provides me in those dialogues for interacting with the file system in the browser. And today my application's separate from that, correct?
Yes, correct. Now, for example, you could always have a client-side application that you could run offline, and you could sort of upload and download files. You would have to use the upload and download dialogues, and you would trigger the download by modifying the file and outputting it as base64 as one of those blobs. But it's not really how a native application feels if you compare that to a text editor, a simple notepad running on your local PC. It always felt a bit like you had to go around what you actually wanted to do. For example, in your text editor, you could just press, on Windows at least, Control-S, or press the Save button. I think on Mac, it's the Mac button on S. And you would not get a download window to ask you where you wanted to save the file that you had previously opened. And so users don't expect that. Users don't expect to be asked every single time, where do you want to save that file? What they do expect is that the application has sort of access to a handle. It can read through that handle, that file handle. It can save through that file handle. And that is where we are headed with web applications as well, or with browser APIs that give web applications access to such functionality.
Now, doesn't that open up a whole lot more attack vectors from the standpoint of a browser and that direct file level access? I mean, we've been working and seeing a lot of these attacks coming through the browser and the power of what JavaScript and ad tracking and forever persistent cookies can do. But direct file access and direct processing power via the browser, that seems like an entirely really bad idea from a security standpoint. I don't know.
I agree. But the thing is, well, first of all, there are some security measures in place. I will speak about them in a few minutes. But when it comes to functionality itself, yes, it does sound scary. So it will even, you have existing client-side attack vectors like DOM-XSS. And in the future, attackers might be able to use that to sort of escalate in the browser to grab that file handle. So yes, there are security implications, definitely. And it's important to be aware of these implications. It's also important to test for them as a security tester and also as a web application security scanner. Now, well, you had some concerns, and I think it's important to keep in mind that in a way it's going to happen anyway. So we can't really just say it sounds dangerous, we don't want to have it at all. In a way, I would say as security professionals, we need to find ways to secure such functionality. Call it the real politics of InfoSec if you want, but in the end, we have to just find a way to make it secure.
Yeah. And
now, do you think? I was going to say, do you think that is finding interesting and demonstrating interesting and unique ways to abuse this? Just from your opinion.
Whenever you have new functionality, I think some people will find interesting ways to abuse it, yes. But the way it works is, initially, when the user wants to open a file for read access, let's start with read access first, then they still get an upload, sort of an upload dialog. And that makes sense, because even when you open your text editor without a file, you want to open a file, well, you have to pick the file at some point. So by opening the file in sort of an upload dialog, you're giving the browser permission to access that one single file. And there will be security measures so that you can't accidentally upload your Etsy password file or your Etsy shadow file. So browsers or user agents will restrict that functionality to certain locations that are not critical. Now, once you've edited your file, you want to save your file. And again, that is permission-based, so you need to, as a user, you need to give permission to allow the browser to access that file with right privileges.
Yeah, it's interesting, Ben, where the responsibility falls, like where protections for this, should they fall somewhat in the operating system, inside the browser, inside the application, or I would eventually guess probably a combination of all three?
Definitely, yes. I would say mostly web browser and web developers. Mm-hmm. Because in the end, the browser has to trust the web application. And if the web application is not secure, then it's very difficult for the browser to tell what the web application is really doing or what it's supposed to be doing, as opposed to what an attacker might cause the web application to do. So yes, it's important to be aware of these features, and it's also important to check for security issues. Now,
yeah,
obviously
like a standard directory traversal bug, right? I mean, a // will now drop you into another directory that you limit it to, but you know, a simple directory traversal vulnerability could allow you to bypass that.
Client-side directory traversal now.
Mm-hmm.
I guess it's up to the browsers to make sure it does not happen. Mm. I mean, like I said, the user has to grant permission to access an individual file, possibly in the future to access a directory, and then the browser will give will pass the application something like a handle, or you could call it a token if you don't have operating system level development experience. Then I would say it's like a token, and the application can use that handle/token to access the file. And it's even possible to store this token in the browser itself, like local storage, IndexedDB, to access it at a later stage.
So if we go back to Paul's original question about the way we've had to change the way we scan web applications, right? Where we needed WebKit, and we've gone through the various different components because we needed to be able to render the DOM at the scanner level. Now what you have to do is you have to have some ability to be locally in the web browser to test some of this new functionality. Is that where this is going, Ben?
That's where it's going, yes, definitely. And that's why it's important that web scanners bring something like their own web browser, because they have to be able to execute client-side functionality, and they have to be able to execute functionality that accesses these new APIs. Now, all these APIs, they will initially be implemented as part of the Chromium project. It's actually called Project Fugu. If somebody wants to look it up, it's Fugu, that is like Foxtrot uniform, George uniform. I think that's how you spell it out. Mm-hmm. And if you run a Google search for that, you will find a list of about 125 APIs, some of them in proposal stage, some of them in development stage, some of them already been developed and in browsers. And it's an interesting read. But yes, to get back to your question, well, first of all, there will be additional APIs. Let me just mention two more before we get into the browsers. And one will be that web applications will be able to associate themselves with file types. So for instance, you open your file explorer, you double-click an image file, and it opens in an image editor. But that image editor could be implemented as a web application. And I think you see where this is going. You have operating system-like functionality that will be accessed by web applications.
Yeah, how do you control? Sorry, Tyler. How do you control which web application is associated when I open an image, right? Because I'm assuming that web application is loaded from a server somewhere.
It could be. There will also be applications, so-called progressive web applications, that can be installed locally. And the benefit to developers will be that they develop once and they deploy in multiple operating systems on multiple architectures, because the browser is, you could say, an abstraction layer. It is operating system agnostic.
Well, just like Java.
Still,
well, yeah.
Sorry?
I said just like Java. Tongue-in-cheek comment.
I'm not going to comment on that.
A container might be a better analogy, Paul, right?
Well, yeah, because like
you
Ben
can run it anywhere.
Yeah, well, like Ben said, the browser acts as that abstraction layer.
Yeah.
So.
Yeah, and yes, like you said, it's important that browsers that web application scanners, they have to bring their own browser. Now at Akinetics, we bring our own browser. It's Chromium-based, and it loads the web page or the website that you are scanning, just to make sure that it can access all the endpoints that your browser would actually access. Sometimes it's not possible to simply look at the HTML code and extract all the endpoints, because they might be concatenated, they may be generated dynamically, depending on user interaction.
Now, are most web application scanners doing this today with the bring your own browser? And does the browser that they bring actually matter for the security testing you're doing?
The browser does matter very much, yes. And at Akinetics, when we first had our own headless browser, that was, I think, 10 years ago. And back then, we would write our own DOM interpreter. And as you can imagine, it's very difficult to keep up with all these new features, with new APIs, with keeping it compatible to what actual web developers are actually using.
Well, and then Ben, you have to be browser specific. If you're writing your own DOM interpreter, not all of the DOM items are available in all browsers, and so you end up with this very complex matrix, right?
Well, at the time, it was, I would say, innovative. But we realized we had to move on. So we moved on to a solution that was WebKit-based. And recently, we moved on to actual Chromium. So now when you scan your website with Akinetics, we access it with Chromium, and we simulate actual user interaction to make sure that you access all the endpoints, that you access all the functionality, and that you actually run the APIs if the web application makes use of them.
So I'm looking at some of these new capabilities, and some of these capabilities look like they're intended to interact with physical hardware on the machine. Is that something you can also simulate, or you just have to return true effectively?
Well, I would say that depends a bit on what you're trying to interact with. For example, take FIDO2, take these physical security keys that you use for 2FA. Now, if you were to write your own web browser, your own interpreter, it would be very difficult to make use of that. But if you use something like Chromium, which has it built in, then it suddenly becomes much easier to use that for login purposes, to actually access your website, to authenticate, to access authenticated areas. So it depends a bit. Now, I know some of these APIs, they are about serial devices. And no, we are not going to simulate a serial device or a Bluetooth device. But I think that is something where you could use our new feature. It's called Business Logic Recorder. And actually, the Business Logic Recorder is pretty much the same as this headless browser, except that we show it to the user. Now, for example, let's say you have cross-site scripting in a high-score list of a gaming website. You have a simple game, let's say tic-tac-toe. You need to get a high score, and only then can you access the vulnerable high-score page. Now, the Business Logic Recorder allows users to record interaction with the web application itself. And a normal scanner would not be able to do that because the scanner does not know how to beat tic-tac-toe, for example. Or you may be booking, let's say, a trip. You have to fill a form on your airline's online shop, on the registration page. And a scanner would find it very difficult to do that in the right sequence. So you can use the Business Logic Recorder to record the correct sequence of steps that is necessary to access the correct endpoints you want to test.
And that Business Logic Recorder runs on my machine, right? So if I have physical devices that have to interact in that process, you would record those steps and be able to perform a scan without access to the physical devices?
As I said, it depends a bit on the physical device. Like I said, things like serial devices are, I would say, very difficult to simulate. So if your website depends on that, it will be difficult to simulate that. But if you use something like FIDO tokens, that is something we're working on.
So you can simulate the token in software.
Yeah.
Well, that might be possible in the future, but it's not possible now because if your website actually requires user interaction with the physical device, yes, theoretically you could fake it, but I don't think it would be the proper way of doing that.
Right.
There, I'm going through this API list, Paul. I mean, there's some scary stuff in here. Virtual keyboard, native I/O, ability to control connected camera, pan, tilt, zoom. I mean, there's some interesting capabilities that are going to get exposed as APIs through these browsers.
Yes, absolutely. And like I said, what is very interesting is that it allows the web application to use these APIs regardless of the underlying operating system. So that means you're running, as a user, you're running Windows or Linux or Mac OS. It should not matter, and neither should it matter for the web application scanner. Now, for instance, we are about to release a Mac OS version of Acunetics soon. We're currently in beta stage. And about 2 years ago, we released a Linux version of Acunetics. And in the past, we've always had a Windows version. So again, because we're using Chromium as a headless browser in Acunetics, it does not even matter what operating system you're using. You're just using Chromium, and you have this headless browser that is able to interact with the application as the designer wanted it to be.
And the user still has controls over what can be accessed. Like, if you go to a website and you want to share your camera, like it asks you, do you want this website to be able to access your device? How is that changing in the kind of newer models?
Well, that's a good question, and it will be very similar to what we have now with webcams, with microphones, with these very sensitive areas. Because obviously, when you offer things like file system access, it's critical to get it right. It's critical that users trust it, or they will just not use it. And actually, I think fugu is a Japanese fish that is poisonous if you don't prepare it right. And I think that relates really well to these new APIs. If you implement them wrong, if you get them wrong, you're going to be in trouble. So you have to make sure that you do it with security in mind, that you design it with security in mind from the beginning.
What's this doing to the complexity of testing now? I mean, it feels like this is really raising the bar in terms of not only what do you got to provide for a harness for testing, but also for what the user has to understand to successfully test fully. Or am I overstating it?
No, I think you're absolutely right. And we have to get to the point where web applications make sure to use these APIs right and to secure the entire web application, not just the access to the API itself, because that should be part of the API design, but also making sure that the application cannot be abused to use the API the wrong way. Now, I think it will be up to web developers to make sure they are aware of these APIs, how they are supposed to work. But more importantly, security professionals need to be aware of these APIs. And right now, I think it will come as a surprise to quite a few people that, like I said, Chrome has file system access already built in. It's hidden behind a flag, but you have the code in your browser already.
How can you test for this before production, right? When we think about developers now having access to build against these APIs, will there be the opportunity to look for some of this stuff statically, or do we have to wait until this browser is actually running before we can actually do some security testing against these new APIs?
What you can do now is that, well, first of all, it depends on the API because there are different levels of progress. As I said initially, they have to go to this process of proposal, development, testing, and so on. Now, some of them are hidden behind a flag. So in your Chrome browser, you have to enable the specific flag to enable the API. Then you can develop a web application, and you can use that web application to play around with the API. That is one way of doing it. And for some APIs, there are so-called origin trials. And what you have to do is you have to go to a specific Google website, and you have to enter the URL of your website. It can be a local staging website, and it will return like a base64 code, essentially, that you put inside the metadata of your web page, and that will enable the feature in your Chrome web browser. So there are ways to use most of these APIs that are in testing stage and to use them for development purposes, but at this stage, not to use them with all users.
Yeah, so essentially you have to test this stuff at runtime.
That was my fear.
Yeah, to see if it's actually accessible or not.
Which now means staging environments become pretty important to test some of these running in a staging environment before you release some of this stuff in production, because you may not be able to catch it, early on as part of some of your static analysis or in your build stages.
Ben,
no, that is
sorry.
Yeah, sorry.
There's a little bit of lag. Sorry. I was just going to ask, what's the difference between some of the Electron-based applications and vulnerabilities and how you would test those versus testing the more browser-native applications that we're talking about for the future?
Well, with the browser-specific applications, I think, as I said, it's important to actually have a scanning solution, have an automated solution that you can use to test for these for security issues on a regular basis. And you need to have a headless browser, and you need to have ways of logging into applications the way that a user would. To get back to, let's say, Fido2 where you need a hardware token, that would mean you also need a headless browser that allows you to interact with these APIs. Now, for instance, at Acunetics, we have the login sequence recorder, which, well, as the name implies, it's a headless browser that is made visible to the end user, the security professional running Acunetics, and it allows you to record the login sequence. Essentially, it's like the business logic recorder. It's a headless browser, but we stream the image of the headless browser through WebSockets to your screen. So you actually interact with the headless browser, and it allows you to interact with the website and tell the scanner how to interact with the website while scanning it.
Ben, how are you thinking about how some of your testing might change? Traditionally we look for things like cross-site scripting and SQL injection in the web application targeting the server side. How do you see some of your tests changing to see how the web application can be abused, not only to maybe exploit stuff on the server side, but also exploit stuff on the client side?
I think they will definitely much more focus on the client side in the future. Now, obviously, just because you add new, possibly dangerous functionality on the client side does not mean that server side loses importance. I think it will just be that in the past, we did not have to focus as much on the client side as we will have to do in the future. And if you have web applications that feel like native applications, then it means that we're also transitioning from purely web application security scanning into something like almost normal application security scanning. So, when you choose a web application scanner, it's always a strategic decision, and not just about the cost of purchase, but also about setting up your systems, about integrating the scanner with your CI pipelines, with your entire DevSecOps environment. And that's why it's important to choose a solution that actually makes sure that it can scan applications not just today, but also in the future. When I say future, I mean in 5 years. And that's why it's important to have something that uses modern technologies and that uses technologies that will see updates in the future, that will be the first ones to access new functionality.
Yeah, it's almost like now we need our scanners to do double duty, right? They're not just looking at server side in abuses of the server. We also have to worry about protecting the clients. So now we have a client side app as well.
Correct, yes. But I mean, in the end, web security has always been to some degree about protecting users. If you think of cross-site scripting, now, of course, implications of a breach would be that you have to protect your business as well. But in the end, you want to make sure that your website is never a danger to users. It's about reputation. It's about liability. But in the end, if your website had no users, there would be no reason to take care of client-side security as much as if you have a website that really allows users to interact with it on this level.
Yeah, and no users means headless browsers everywhere.
Well, but it's interesting too because there's
headless users.
The security of your application can impact the server side or the user side, but there's also now with a lot more functionality in the browser is really a vulnerability scan that needs to happen in the browser, because a lot of this depends on how my browser is configured, if it's configured properly or not, in addition to how the web application is coded and configured as well, correct?
That is correct, yes. And like I said, sorry?
Oh, I was just, sorry, I didn't mean to say that out loud. I just thought, does that mean you're now also going to have, instead of just, say, the most current headless Chromium, are you going to have different versions to simulate different vulnerabilities? That didn't come out well. Basically, you're going to have a library of Chromium headless browsers for people to choose for different behavior.
Right. Like, is my browser configured securely or insecurely, and how does that impact any vulnerabilities in the web application?
Well, there are ways to disable certain features, security features in Chromium, in headless Chrome. So you do not really need to use an older version. Well, okay. Of course, it might make sense. But in general, what we've seen so far is that it's sufficient to disable security features on purpose to sort of emulate these older versions that did not have the security features in the first place.
Yeah,
right.
Ben, do you see this interesting kind of correlation between some of the endpoint products now and the web app scanners, because maybe the endpoints can give you some of this local client-side data from the browser? I mean, do we see a world where the web app scanners may need some information from some of the endpoint guys to give them some of the contextual information they need about how the browser is configured or different components of the operating system to correlate back to what these new Chromium web scanner browsers are doing?
I'm not quite sure if I understood the question.
Or do you not need it? Are there things at the client side, at the OS layer, from a configuration perspective, like in the browser, that you can't get from these headless Chromium browsers, for example, that you need to correlate with, and therefore you need some, maybe an endpoint product or something like that to give you some of that data?
Oh, I see. No, it should not be that way. For a security scanner, it should be sufficient to have access to the headless Chrome browser. And well, on top of that, we have much more than just a headless browser. We have the actual crawler. We have the actual scanner that checks for vulnerabilities independently of the headless browser. So the headless browser is really just one component of the entire scanning solution.
But it's more browser specific than operating system specific.
Yes, absolutely.
Yeah, so I think what we want from folks like Acunetics is a way to test my browser to make sure it's secure without having me install like 8 million browser plugins, which to me just opens up more of your attack surface.
That is correct, yes. Well, and to get back to Chromium, the reason why I mentioned it in the beginning, why it's so important to use a headless browser in your scanning solution that is actually modern, that is going to see a lot of updates, and that is going to have access to these new APIs. Sometimes our salespeople, they ask me for assistance with technical questions from prospects, from potential customers. And so I see exactly what customers are concerned about, what questions they're asking. And one question that never comes up is, what headless browser are you using? And I just think that many people are not aware of the importance of the headless browser, that you have one in the first place, and which one you're using. Because if you're not using the right one, there's just no way to test functionality that you don't have access to.
Right, and then it also comes down to the configuration of that headless browser. Is it mirroring how I'm configuring my browsers for my enterprise, or not? So it's an interesting intersection between, browser and client-side security, the applications that live on the client, and the web application itself.
That is correct, yes.
I hear it beeping. I don't know what that was.
I hear beeping as well.
Oh, okay. No worries. So when can we expect some of these APIs, and how do we keep tabs on them, Ben?
Yes, I think that's very important, not just for developers, but like I said, also for security professionals, because you don't want to be surprised by this. You don't want to wake up one day and find out, hey, my web browser can access my file system. And so one way of doing that is to follow the project FUBU. As I said, it's FUGU, Foxtrot Uniform, George Uniform. And they keep track, or they keep a list of all proposed APIs. And they have sort of a table that tells you exactly what is hidden behind a flag, what is available through these so-called origin trials. And that is a very good starting point. It's being updated regularly. Personally, I like to check it every few days just to make sure that at Acunetics we stay on top of these things. And if what we've talked about so far sounds interesting, I can only recommend looking that one up, Project FUBU.
Awesome. Yeah, and there's links in the show notes at wiki.securityweekly.com that take you to all of the resources.
One thing I would like to mention is that even though it's, I wouldn't say Chromium specific, but clearly driven by Google, there are different companies involved. There's Microsoft involved, there's Intel involved, there is, I believe, Samsung involved. So it's not just one Google thing. These APIs are coming to all browsers, to all important browsers sooner or later. So it's important to be aware of these APIs.
And I'm assuming these will also be available on the mobile side as well?
Correct, yes. And that's just great for developers. You can develop your app once, and you run it on different operating systems, but also on different devices. And to get back to the native file system access, on a smartphone, you have a very different file picker than on a classic desktop operating system. And these APIs will take care of all of that to make sure that users really use and see what they're used to.
And that's not just a web browser running on a phone. That's also apps running on a phone that are accessing the web browser, correct?
Correct, yes. And you bring up a very interesting point, because in the past, you would often see these very cheaply made apps. They would do nothing more than opening like an integrated browser,
Right.
and it would just show the website of the developer. And well, why would they do that when they could just tell the user to go to their website? And the answer was usually that the website would not have access to all the functionality through the web browser. So you have to combine a sort of native app with the web browser control to show new content, while at the same time having access to OS level functionality. And I think with these new APIs, that should be a thing of the past, and hopefully we'll have access to more native web applications.
Less apps on my phone. I like it.
So let me step in here for a quick second. For those who don't know Acunetics very well, let's talk about some of the backend structures, if you will. What does Acunetics output vulnerability data into? Right? Is it a JSON file? Is it an XML? Right? How is Acunetics interfacing with other systems like Splunk and so on and so forth?
Well, we have a number of integrations, so you can push vulnerabilities directly to your bug tracker or your issue tracker system. So actually, we've made great improvements in that regard over the past few years to make sure that Acunetics can be part of your pipeline, of your development pipeline, of your entire DevSecOps operation. And I think we have access to, let's say, Jenkins now as well. But your initial question was about how we output vulnerabilities. You can, of course, also output them as reports with different reporting types that map to well-known vulnerability frameworks. So in the end, there's something for everybody.
Well, the reason that I was going down that road is earlier you were talking about the tic-tac-toe of how headless Chromium, right, does pay, does authentication, does a whole bunch of stuff, right? Is that translated over to the bug tracking utilities, or is that something that's only native to Acunetics?
Well, no, that is only needed actually for vulnerability scanning. If you speak about the access to the APIs, if I got the question right.
Well, so inside of the business track, right? I was looking at Acunetics' website and your blog release on how this comes together, and it's showing all of the steps that need to happen, right, inside of a web app for an action, right? So you're playing tic-tac-toe through the steps. I'm asking, is the tic-tac-toe, is that reported in the bug tracker? So if I'm a developer and I get a bug report from Acunetics, right, security guy says, hey, we've got a critical vulnerability. Here are the steps that needed to happen. I log into a bug tracking utility, whether it's Jenkins, whether it's PlexTrack, whether it's whatever else, right? Is that tic-tac-toe shown in the bug tracker, or does the developer have to go back to Acunetics? Like, what I'm saying is can you put all of the information in one place, or do you still have to go back to Acunetics platform to be able to see the action taken?
No, we absolutely make sure that all the information is in one place, be it your issue tracker, be it your report. We want to make sure that you have one document or one page to look at, and that is all you need.
Love it. I'm good. Thank you.
Fantastic. Any other questions for Ben? Outstanding.
Good.
Ben, thank you so much for appearing on Paul Security Weekly. Folks that want to learn more can go to securityweekly.com/Acunetics. Ben, again, thanks for appearing on the show.
Thanks for having me.
And with that concludes the show. This is the last segment, right? Pre-recorded last segment. Thank you everyone for listening and watching. We'll see you next time. Over and out.